Okay, so hi everybody. Please welcome Carlos de la Guardia, presenting 5 powerful pyramid features.
Hi. So a funny thing happened to me on the way to the forum. I lost my slides. I lost my computer, and then I borrowed one, and I used a temp session, and I didn't know it, and so everything was gone. So I'm still going to give the talk because I have some slides from another presentation I did. It's not exactly the same, but we'll have to manage. I apologize for that. So here we go anyway. So Pyramid is a very flexible framework, and it allows you to choose from a really big set of features that we think are very great. And they're just not features that are specific to Pyramid. Some of those features are stolen from other frameworks like Django or Flask. So we have many features that come from different frameworks and different experiences. I don't know if many of you know about this, but Pyramid comes from many concepts on Pyramid come from the years of SOAP, the SOAP application server. So we also have features that we stole from there. And Pyramid allows you to pick what you want to use. You don't have Django, for example, is a full stack framework, and you have to use everything that Django gives you, or to get the best experience possible. It's better if you use the ORM and if you use their templating and if you use everything, because that's the way it's built. Pyramid the design of Pyramid has this idea that you should be able to build the smallest application without the framework getting in the way, and you should be able to build a large application and have everything work fine. So it's extensible. It has many pluggable points. It's really flexible. You don't have a backend that is enforced, a persistence backend enforced. And well, we like that, and it's very flexible. But it could be daunting for someone starting with the framework, because there are a lot of choices and not enough time to some time. So Pyramid tries to help you decide sometimes. You can have scaffolds that make decisions for you. And we strive for keeping everything completely documented, so there's always an informed choice behind what you decide to do. So you go to the docs and you can look at everything. Everything that we can do is on the documentation. So there are some features of Pyramid that make setting up a project a good experience. But you have to still decide about how you are going to lay out your project, what persistence mechanism you're going to use, how you're going to assemble your toolkit. You can pick an object database or MongoDB or SQL Alchemy. There are some concepts that we have, like traversal, that are specific to Pyramid, and no other framework offers them. And we have super flexible view configuration. Well, I'll skip this. This is a typical project layout. I'm not going to go into a lot of detail here. But the scaffolds create the project. And we usually recommend to keep separate files for modules for everything, that if you want views on some modules and templates, the scaffold layout tries to be somewhat modular and allow you to. Yeah. When you have a larger project, you can use folders and directories to keep your files in some order. So as your project is growing, Pyramid does not enforce any layout on the file system. So you can basically choose whatever you want. So we usually recommend that as the project grows longer, if you start with a simple application, you can do it in one file. Pyramid allows you to do that, just one file, the whole application. And you can grow with it. So your project, as your project grows, you can refactor stuff and put it there, and it doesn't affect the code in any way. So you, throughout the project lifetime, you are free to move around stuff without any big cost. And you don't need, for example, if you are doing a Django application and you don't want to have any models, you still have to have a models PY file there, because if you don't, it doesn't work. Pyramid doesn't enforce that kind of thing, so you're free to put your files however you want and wherever you want. So there are several persistence backends that you can use. SQL Alchemy, there are a lot of ORMs. You can also not use any ORM and directly connect to a DB driver. You can use MongoDB or something like that. You can use CODB, which is SOAP Object Database, an object database that's pure Python, and that we like a lot. But many people do not like object databases, but it's an option. And Pyramid has support for transactions throughout the request. So when the request starts, a transaction begins, and the whole request is contained in that transaction. So if there's an error somewhere in the transaction, all your database commits and everything gets rolled back, and you avoid getting into incoherent states for your data. So that's a very cool feature. For example, you can configure it. If you want to send an email after something finishes, the email will be sent only if the transaction commits successfully, and if not, it will not be sent. And if you want to commit some information to the database and there's an error, it will roll back and you will be left in a consistent state. It also allows you to hook up multiple backends. So if you have an SQL database and the CODB and the email program, they all can be hooked up to the same transaction manager. So if anything happens, all three systems will roll back and not leave you in inconsistent states. So that's one thing that we like very much in Pyramid, the transaction management. So to pick which backend you would use, you have to actually look at your data and select what it looks. We don't think that there's one solution. We like the CODB, but we don't think it applies to every kind of project, and we like relational, but same. We don't think it applies to everything. Pyramid is pretty flexible as well in regards to templating languages. You can use basically whatever you want. Chameleon, Mako, Jinja 2, or you could even create your own template rendering and use it. It's really simple to make a templating backend plug into Pyramid. So these three that are here, right now they exist. Pyramid comes with Chameleon and Mako, and there's a Pyramid Jinja 2 package that allows you to use Jinja 2. And one of the reasons that Pyramid allows to easily change templating languages is that it has a concept of renderers, which is one of the features that I wanted to talk about today. A renderer actually takes a view, the result of a view, and renders something like a template. That allows you to, in your view code, only use return, instead of returning a response, a web response, you only return dictionaries or any data structure. And what this does is that it's very easy to test your code because you only focus on the data that you're returning. You don't need to test the response object, and you don't need to construct some testing mock objects to mock the response or anything, because you only focus on the actual results of the view. So the actual view processing is independent of the rendering, and that allows us to plug in any number of renderers. For example, we have JSON renderers, we have text renderers, and the different templating renderers. And you can easily make a renderer for some kind of file. If you want to do direct XML, render XML RPC or whatever, you can do that. If you have a specific XML dialect that you need to use, you could easily make a render and plug it in and just configure your view to use that instead of a template, and that will work. So that's a piece of flexibility that we like very much about Pyramid, and it makes it even more easier to adjust to different project requirements. And there are also a lot of libraries to handle form generation. The form from Alchemy, Formish, Simple Form. So, like I said, it's really flexible. You can pick what you want. Same with authentication. Pyramid has security model integrated, which is one of the features that it has, so that you can, out of the box, have a session and then secure session with, well, not secure, but permission-based session. So you can assign a permission to a view, and Pyramid will know if some user has a permission to access the view or not. So Pyramid offers two mechanisms for finding views. In Pyramid, we have a process where you define your URLs, and then there's a separate process that we call view lookup that once you have a URL matched, we find which view can apply to your data. And the classic mechanism for doing that in most frameworks, in Django and Flask, and also in Pyramid, is called URL dispatch, and it allows you to use regular expressions to decide which views match something. And we have another mechanism that comes from SOAP that's called traversal, and it allows you to create a tree of resources. So instead of having a URL match an expression, you create a tree of resources that could be any models that you have, any objects that you create. And the only condition is that they have to be dictionary-like. They should respond to the getItem method. So they behave like a dictionary in that respect. And when you do a URL, each segment of the path is actually interpreted as a resource. So it goes through the URL and tries to get it's really like a file system. Imagine you are the root of the file system, and that's the root URL, and then all the resources are, say, there. Traversal is somewhat more difficult to understand than URL dispatch. So many people freak up a little when they hear about it. But it's really like a file system. You have a root object, and you can traverse then and go inside a folder and inside a folder and inside a folder. And that's great for sites that require, for example, arbitrary extension. If you are going to give your users the permission to create a folder, for example, and inside the folder put different kind of documents, it becomes a bit hard to create a matching URL pattern that will know exactly how to do that. It's possible, but you would need really large or difficult regular expressions. With traversal, you don't need that. You just created the tree structure, and traversal takes care of getting to the file that you need, to the URL that you need. And this also allows you to have really good granular security, because each resource can have an ACL, an access control list, and that way you can make, instead of just does John has permission to reach this URL, it becomes, does John has permission to edit this precise document? So that's a lot more granular, row level security. Okay, Pyramid allows you to use declarative configuration and what we call imperative configuration. Basically, imperative configuration means that you have a file and the init of your package, and there you include a bunch of add view statements or add route, and And all the configuration is on this file. And declarative configuration is different. It's when you have a view and you want to have the declaration close to the view, so you use decorators to do that, and then you can scan the code when it starts, and it gets all your configuration information. The view configuration in Pyramid is really one very cool thing. The request in the web request in any HTTP client, it has so much information, and most frameworks only care about the request method. You might have seen a lot of code that has an if statement. When you have a view, if method equals post, do something. If that method equals get, do something. And for example, if the form was submitted, you have the if method equal post, and you know that the form was submitted, and then you create the object and save it or something. In Pyramid, instead of that, we allow you to have view declarations that basically allow you to declare multiple views for the same route. And then you have these predicates that do the actual distinction between views. So there are a few examples there. You can have a view that uses a predicate for route name, request method on XHR, like if you want to do an AJAX view, something. And this allows you to put the code for a view completely separate from the other one. You don't need an if statement. You just configure the view to be used whenever the method is post, for example. Or you can do things like if there's a request parameter that's called submitted, use this view. So the view code is a lot cleaner because you only have the code for the actual thing that you're going to do, be it a post or a get or whatever. And you don't have to put ifs anywhere in the code. You just do the view declaration and select some predicates from there, and Pyramid takes care of looking up the correct view and giving you the right result. This is great for testing because the code is clean and you only have one result to worry about. You don't have to take into account any branching, and it allows the code to be really compact. The view configuration also allows easy HTTP caching, so you can take a look at that and see that assigning HTTP cache of 3600 allows you to cache a resource for an hour, and Pyramid sets all the correct headers and to do that. One other thing that Pyramid allows you, it's the view callables can be anything. They can be a function, they can be a class, and they can be even an instance of a class. And that's convenient sometimes when you want to have some similar code together. For example, let's say you have a checkout view in a store, and you have those checkout views that you first fill out the address, then fill out the shipping address, the billing address, and then confirm your order, and you have like 4 or 5 different views that all are related to the same thing. So all of those views need the cart, all of those views need access to what's on the cart and all the information you are capturing and at what stage you are. So Pyramid allows you to generate a class that generates a dictionary with that, and you have a common initialization for that. So this is an example. You have a view and it's a class, and you can have the decorators there that you see, view config. They are the ones that are responsible for configuring the view. So in this case, we have the class, and each method, view1 and view config, are different. View2, sorry, are different views on your class, but they both have access to the same information in the init. When Pyramid gets to the view and finds the correct view, it creates an instance of this class. And when it creates the instance, you get the request, and you could put all the checkout information there, and all the other views will just get that, and you don't need to repeat passing parameters to all the other views or get information in other way. It will be all on the initialization. So these class method views are great for when you need to have some code that does related stuff in one single class, and you can share the configuration. Pyramid is also extensible in many ways. There are many mechanisms that allow you to compose or extend applications. It has a unstructured configuration mechanism with includes, and you can say you have to create a configurator when you start a Pyramid application using the Pyramid's configurator class, and when you do that, it starts a configuration transaction, and you can at that point add views, add routes, static assets or whatever, and it's all structured. And if you keep that in a separate module, for example, in your code, you could call that initialization from an external application. So you can reuse application code from another application, just calling config include, and you will get all the initialization from that. That also allows you to actually override things. Let's say you have this application and you want to add a view, but you really like the application and it's almost perfect for what you need, but you need another view. You need some different view or something. So you can just call the configuration for that in a new application, and in your new application can have just this one view. And this, you call the configuration with config include, and then you add your view after that, and you will have an application with that view and all the other views and routes and stuff from the original application. So you can actually extend an application without needing to fork it. You don't have to fork it and rewrite it or anything. You just create a new package and extend that directly. And Pyramid can do that not only with views and stuff like that, but also static resources. So if you want, for example, to just override one template in an application because you have an application, but you want to add the corporate logo somewhere, you can do that, and you can just have a new package that only has the logo and overrides the logo resource from the other application, and you can extend it that way. So that is useful for third-party applications, but it's also very useful if you want to have some kind of framework on top of Pyramid. If you use Pyramid in a corporate setting and you have some sort of code that you always need to reuse, it can be very useful to have some sort of mini framework on top of Pyramid that has all of those configuration settings in different modules, and then from another application you could just call whatever you need from the master framework that you created using config include, and create an application based on top of that, and just use what configuration you need and override whatever you don't need. So it's really very flexible for extending, and since Pyramid doesn't use globals like, for example, Django settings, you can run even different configurations in the same process, which you cannot do, for example, with Django settings. So this is what we call asset specifications. An asset specification identifies a static asset inside a package. So all throughout Pyramid, we use this to refer to static resources. And this allows us to override any static resource that we can use in an application. So let's say you have this static file, a CSS file, or a page template, or whatever. You can use config override asset when you are doing your Pyramid configuration, and specify which resource to override. Since you can specify the package and then the directory inside the package, you can practically override anything that you can import in Pyramid. So any Pyramid application that has any resource specified using asset specification can be overridden. And so you can override it with another. In this example, we have a template inside the some package called my template PT, and we want to change that. And we want the same view, we want the same data that we're getting, but we need to have a different template design. So override with gives us the path to another package, which is called another package. And it has its own templates directory. And this another template.pt is going to override my template PT. So when the view that is going to display is looking for the renderer to get the template into an HTML page, instead of getting my template PT, you will get another template PT. And that way, you can use all the view data and information that comes with the view in that new template. So that's that mechanism. So well, all those things that I mentioned are very good for testing because you can keep very compact code and it doesn't depend on other stuff. So anyway, those are the features that I wanted to make. I've run out of time, so I don't know if there are any questions. Thank you very much.